In this video, we're going to look at one of the classic kinds of algebra word problems that you'd probably find in any algebra textbook is distance problems. Problems involving cars or bicycles or trains or something like that going at a certain rate of speed for a certain amount of time, covering a certain distance. And the key fact here is the relationship between those two things is distance equals rate times time. And you can also rearrange that. Right now it gives distance in terms of rate and time, but you could divide both sides by rate and say time equals distance divided by rate. Or you could divide both sides of this equation by time and say rate equals distance divided by time. But that means if you know any two of those things, you can figure out the third one. For example, if you were going 70 miles per hour for 2 hours, you would cover a distance of 140 miles. Now, if you just knew the distance and the time, you knew you covered 140 miles and it took you 2 hours to do it, you could divide to get your rate of speed, 70 miles per hour. If you knew you were going 140 miles, and you knew your rate of speed was 70 miles per hour, and you want to figure the time that's going to take, then you would divide the distance by the rate of speed. 140 divided by 70 is 2. So you can always figure out one of those things if you know the other two. Now that's assuming that your rate of speed is either the exact same the whole time, you're driving at a steady 70 miles per hour, or maybe sometimes you're going a little faster, sometimes you're going a little slower than that, but that's your average rate of speed. So in these problems, we're assuming that either we're driving at the same speed the whole time, or if it varies, we at least know the average rate of speed. Now let's look at an actual example of a problem like this. Michelle drove her empty rig 300 miles to Salina to pick up a load of cattle. When her rig was fully loaded, her average speed was 10 miles per hour less than when the rig was empty. If the return trip took her 1 hour longer, then what was her average speed? So notice what's going on in this problem. She drives the empty rig 300 miles to Salina, picks up a load of cattle, and drives back to where she started from. So another 300 miles. So we have two trips. In problems like this, we either have two different trips or we have two different vehicles or something like that. But here we have the trip going to Salina to pick up the cattle, and then we have the return trip. Those are the two rows of the table here. Now let's see what we can fill in. Do we know the distance? Do we know the rate of speed? Do we know the amount of time? We do know the distance. We know that from her starting point to Salina was 300 miles. And then the return trip was also 300 miles. So we can go ahead and fill that in. Do we know the rate of speed? Well, actually, that's what we're trying to find. What was her average speed? We don't know that, but we do know that when her rig was fully loaded, her average speed was 10 miles per hour less than when it was empty. So like, if she was going 70 miles per hour on her way there, she would have gone 60 miles per hour, that's 10 miles per hour less, on her way back. So maybe it was 70 going to Salina and 60 coming back. Maybe it was 45 miles per hour going to Salina and 35 miles per hour coming back. Maybe it was 90 going there and 80 coming back. But whatever it was going there, it was that number minus 10 coming back. So let me just fill that in with x and then x minus 10 for the rate of speed going to Salina and then coming back. So we don't have actual numbers for the rate of speed, but we do have a variable or variable expression to stand for that. Do we know the time? Well, no, we don't know how many hours it took her to get to Salina or how many hours it took her to get back, just that the return trip was 1 hour longer. So it might have been 2 hours and 3 hours, might have been 12 hours and 13 hours, might have been 6.5 and 7.5. But once we have two of these columns filled in, we can use what we have in those two to fill in the third one. Remember, I said time is equal to the distance divided by the rate of speed. So if we take whatever's in the distance column divided by whatever's in the rate column, that gives us something we can put in the time column. So 30 divided by x for the time to Salina, and 30 divided by x minus 10 for the return trip. Now the return trip, the time there, was 1 hour longer than the trip to Salina. The time for the return trip was 1 hour longer than the time to Salina. That we can translate into an equation. The time for the return trip, 300 divided by x minus 10, was equal to 1 hour longer than, so we added 1 to the time to Salina. We took 300 over x and added 1 to that to get something that was an hour longer than that. So there's the equation we need to solve. Okay, I see two different denominators. I want to eliminate both of them. So I need something that's a factor of x minus 10 and of x. It needs to be divisible by both of those. So let me just multiply them both together. So I'm going to take x minus 10 times x and multiply both sides of this equation by that. So when I do that and I cancel what I can cancel, I get 300x, because the x minus 10 over x minus 10 divided out, equals 300 times x minus 10, because the x over x divided out, plus 1 times x minus 10 times x. Nothing divided out there. Now when I multiply things out, that's 300x equals 300x minus 300 times 10 would be 3,000, plus 1 times x is x squared, and 1 times x times minus 10 is minus 10x. Now this is a quadratic equation because it has an x squared in it. So let me try to solve this by getting a 0 on one side equal to whatever we have on the other side. To get a 0, might be easiest to get a 0 over here by subtracting 300x on both sides. And then I have the x squared, the minus 10x, and the minus 300 together on that other side. Can I factor that? I would need numbers that multiply to negative 3,000 and add to negative 10. And you might have to think about this a while or play around a little, but it turns out that the factors are x minus 60 times x plus 50. If I multiply that out, I get x squared plus 50x minus 60x, so there's my minus 10x, minus 3,000. So now x minus 60 equals 0, or x plus 50 equals 0, which means x equals 60, or x equals negative 50. So we've solved the equation, but how does this relate to the actual problem that we were trying to solve? So x stood for the rate of speed going to Salina. And x minus 10 was the other thing we were trying to find, the speed coming home. We got that x was 60, or negative 50, but the positive one is the one that makes sense here. So if x is 60, x minus 10 would be 50, and there's our answer. She went 60 miles per hour on her way to Salina and then 50 miles per hour on the return trip. That was fun. Let's try another example. Two cars leave the same point and travel in opposite directions. One of the cars travels 4 miles per hour faster than the other one. After 3 hours, the distance between the two cars is 378 miles. Find the rate of speed of each car. So here's what's going on. We got these two cars. They leave the same point, and they travel in opposite directions. And then after 3 hours, the distance between them, how far apart they end up at, is 378 miles. And we're trying to find the rate of speed of each car, how fast each one was going. We don't know the distance for either car separately. We know the total distance between them is 378, but the first car didn't go all 378 miles by itself, and neither did the second one. So we don't really know how many miles one car or the other went by itself. So we can't fill in anything for the distance yet. What about the rate of speed? Well, that's what we're trying to find, but we do know that one of them is 4 miles per hour faster than the other. So we could use x and x plus 4 for that. Do we know the time? Well, actually, yes, we do. It was 3 hours. So 3 hours went by. Each car was driving for all 3 of those hours. Time for the first car, 3 hours. Time for the second car, 3 hours. And once we have 2 of those columns filled in, we can use them to put something in the third column. Here we have the rate and we have the time. And if you multiply those together, you get the distance. So for one car, it's 3x. And for the other car, it's 3 times x plus 4. Now, where's the equation going to come from? If we add those two distances together, the 3x miles that one car went, plus the 3 times x plus 4 miles that the other car went, that gives us the total distance of 378 miles. So 3x plus 3 times x plus 4 should equal 378. There's the equation. If we solve that equation, we will have our number for x, and then we can easily figure out our number for x plus 4. Okay, let's start by getting rid of the parentheses. It's nice there's no fractions in this one. So 3x plus 12 equals 378. Combine x terms and we get 6x plus 12 equals 378. Subtract 12 on both sides, we get 6x equals 366. Divide both sides by 6, we get x equals 61. And that was one of the two rates of speed. That was how fast one of the cars was going. And the other one was going x plus 4. So now that we know that x has to be 61, the other rate of speed, x plus 4, would be 61 plus 4, which would be 65. So one car went 61 and the other went 65 miles per hour. I'm going to run real quick through another example if you want to see it. You can pause the video and look at each step if you want to see how I'm doing this. But a commuter drove 24 miles to work and then returned home following the same route. Since there was less traffic going to work than on the way home, she traveled 10 miles per hour faster going to work than coming back. She spent a total of 2 hours driving to and from work. What was her average rate of speed each way? So here we got 2 trips, going to work and then coming back home. We do know the distance for each one. That's 24 miles. The rate of speed is what we're trying to find. It's x, and then 10 miles per hour faster than that would be x plus 10. And then we can figure out something to put in the third column by using the first two. Time is distance divided by rate of speed. So 24 divided by x and 24 divided by x plus 10. Then that's a total of 2 hours. So adding those two times together, they should equal 2. That's the equation we have to solve. Here are the details of solving that equation. We end up with x equals 20 or negative 6, which doesn't really make sense. But then the answer is She went 20 miles per hour going to work, and then 20 plus 10 is 30 miles per hour coming home.